MDM4U 2.5 Measures of Central Tendency. Measures of central tendency are different ways to describe the middle of a set of data. Measures of central tendency starting with the mean. The mean, we have two different types of means. If we're taking the mean of a population, there are special symbols that are used for this situation. So mu is a Greek letter which represents the mean of a population. And we're still going to do the same thing as before. We're going to add up all of the values in the set and then divide by capital N, the number of elements in the set. Notice here that compared to the sample mean, we have a symbol for each that's different. Mu for the population mean, X bar for the sample mean. We're still going to add all of the elements in the sample and divide by lowercase n, which is a different number than capital N because a sample typically has less values than the population, or less elements than the population. It's usually a subset used to try to get information about the population. So, that being said, be familiar with each type of mean. It will be relevant in future chapters. Next, median. The middle value of a set of data ranked from lowest to highest. If there is an even number of data, the median is the midpoint between the two middle values. Next, mode. The value in a distribution or set of data that occurs most frequently. So, there can be more than one mode. If that's the case, express it as mode is equal to, and with the open and closed bracket for a set. Example, determine the measures of central tendency for the set of data. So measures of central tendency include mean, median, and mode. So here is the set of data. It's not in order, but that's not necessary for the mean. The mean, we can add these up and divide by the total number. So, that being said, the total when added all together is 858, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements, n. When we divide, the value is 71.5. So this is sometimes referred to as the calculated middle, or average. The median is the middle number by position as far as the rank is concerned. So we have 12 elements, but we have to make sure that this is in order from least to greatest to find out where the middle is. If there are 12 elements, that would mean that 6 on the left, 6 on the right gives us the median. So if it's in the middle of these two, 65 and 78 are added together and divided by 2, which is taking the midpoint in between these two, and that is the median. So the advantage of a median is that if there is an outlier, let's say that there's a student who instead of 46 got 8% on a test, that would drastically affect the mean. The mean would drop significantly, but the median would be unaffected. So for that reason, the median has its advantages when there are outliers in the data set. Mode. The mode is the most frequent, so it's helpful to refer back to your list in order from least to greatest, because then if we have repetition of numbers, they're listed adjacent to one another. 57 and 57, as well as 79 and 79. So we can use the brackets for set notation to imply that there are two modes. And if there was, say, for example, there was 98, 98, 98, the frequency of 98 was 3, then we would just say that the mode is 98. So it's the list of the numbers with the highest frequency. And if there's a tie, list each of those numbers. So as mentioned, the mean is affected by outliers in the data set. The median is not affected by outliers and can be more reliable for small data sets. The mode is best for situations where the measures of central tendency must be of value within the set. So if we're talking about, say, for example, shoe sizes that are sold in a store, if the mean tells us that shoe size 10.739 is the middle number, that's not going to be helpful to us in any functional sense. We're going to need the most frequently occurring if we wanted to maybe supply the right number of shoes in the store, or the right size of shoes with the right frequency. Next, so weighted mean. That means that certain numbers in the data set are given more significance. I'll read the definition. A measure of central tendency that reflects the greater significance of certain data. So this is the definition. The weighted mean is the sum of, and we're going to take the weight times the actual outcome in the data set. So X is always representing the score for the category, and this is divided by the sum of the weights. So we'll use this as our example. The following table summarizes the weighting criteria for a job interview, as well as the score out of 5 for the 2 jobs candidates. So there's 2 candidates, Anna and Ben. The weighting for each of the different categories is given here, and it seems like there's a lot of interest in actual skill for this job. But the scores that they have, our X values, are listed here. What we're going to do is, for each person, determine each candidate's weighted average. Applying this formula, the weight times the actual score. So let's go through Anna's first. 5 times 4 plus 2 times 5 plus 1 times 2. That's the weight times the score for each category. Divided by the total of the weight. So add the weight for each one. And when there's no upper limit or lower limit, that just means to add all of the weights. In this case, it's 5, 2, and 1 all together. We get 4 as a weighted average. And if we were to add this together, divide by 3, that would be an unweighted average, just for reference. But for Ben, if we do the same thing, the weight times the actual score, this is going to give them 5 times 5 plus 2 times 1 plus 1 times 4 for the weight times the score in the numerator. In the denominator, same thing, add 5 plus 2 plus 1, and the weighted average is slightly lower for Ben, so the job should go towards Anna. Next, what we're going to do is talk about measures of central tendency for group data. When data is grouped into an interval, the measures of central tendency can be estimated using the midpoints and frequencies of the intervals. So let's talk about this right here. This is a histogram. We know that it's a histogram because the x-axis has an interval or a range of values that are being represented here. So the issue with a histogram is that there's a lack of precision for the actual heights in this category. So let's say 180 to 190 centimeters, there are 4 individuals on the basketball team. And we don't know the exact height of any of the individuals in this range. So what we can do is take the midpoint for 4 individuals. So the midpoint here would be 185, and use that midpoint to represent this bar. So it's like we here in the formula, we'll get to that momentarily. So for the grouped mean, what we're going to do is take, so the mean subscript group, member subscripts represent name, this is the grouped average. What we're going to do is take the frequency of that outcome multiplied by the midpoint of an outcome, so that interval, divided by the total frequency. So let's take a look at the first example. Here, the midpoint is 175, and its frequency is 2. So the sum of FMI, we're going to have 2 times 175, 4 times 185, 1 times 195, 2 times 205, and 1 times 225. Divided by the sum of the frequencies. So the numbers listed were 2, 4, 1, 2, and 1. This calculation tells us that the middle number is 192. Okay, and this is again an approximation because we don't actually know the values within each of these intervals, but it is going to be the best approximation we can do. That being said, the cumulative frequency can be used to locate the interval that the medians belong to. The midpoint of the interval is used as an estimate for the median. So, this is where we can apply our cumulative frequency. We just took this information that is in our graph and expressed it in this table, the height and the frequency. So, that being said, if this is the frequency, the cumulative frequency is like a running total. So 2, and then we add 4 to make 6, we add 1 to make 7, add 2 to make 9, and so on. And we get a cumulative frequency of 10. So the median is the middle number of 10. That would be 5 on the left, 5 on the right. So it happens between the 5th and the 6th element, which the 5th and the 6th element, that's going to be occurring here. So, that being said, the 5th element occurs after this interval. Therefore, we're going to say that the median is the midpoint of this interval, 185. So I hope that that's clear. The 5th and 6th element belong to this set. Let's just illustrate that a little further. 1 and 2 belong here. 3, 4, 5, and 6 belong in this. So 5 and 6 is inside of here. Our median is that midpoint, 185. Just a visual with a graph. Lastly, mode is the most frequent. So the interval with the highest frequency is 180 to 190. As you can see here with our graph. So this is considered to be the mode.